Welcome back. Today we're going to start with some notes about climate. This is the first set of notes in a series that we're going to do this week. So you need your notebook, you need something to write with, and you need a set of headphones to listen to these notes. We're going to talk a little bit about what climate is, how it's measured, and how it's classified in this set. So first off, talking about the definition of climate. Climate is an average of the weather conditions in an area over a long period of time. We're talking decades. Um, this includes temperature, it includes precipitation, air pressure, winds, cloudiness, any of those conditions that we've talked about already. When we're talking about climate, we're not talking about the day-to-day weather of a place. If we're looking at a 10-day forecast, or if we're saying that it rained last month, that's not part of the climate that we're talking about. That's just day-to-day weather. If we were talking about climate, we'd be talking about an average of how much it rained last month over the last 30 years. So an easy way to remember that, the difference between weather and climate, is the saying, climate is what you expect, weather is what you get. So we said that climate is an average over a long period of time, usually about the minimum period of time that we have to look at if we're determining the climate of an area is about 30 years. In some cases, if we have a lot of data on a particular region, we might look back even further than that. But 30 years gives us a good time period to get an average without or with taking into account changes that might have happened in that area in the climate over time. If we're looking back at the climate 300 years ago or 500 years ago, we'll notice that the climate is significantly different. It might have been much colder, it might have been much sunnier. It just depends on the conditions at that time. One other important thing to keep in mind is that no two places on Earth have exactly the same climate. Climate is made up of a number of different factors, and the main 8 that we're going to talk about are latitude and the amount of sunlight that a place gets, its temperature, its air pressure, wind, humidity, clouds, precipitation, and one of the most important ones is its geography. A couple of other terms that you should know when we're talking about climate are climatology, climatologist. Climatology is the scientific study of climate, and a climatologist is a scientist who studies climates. Okay? There are several organizations that you're going to be seeing a lot of over the next couple of weeks that track weather and climate. That includes the World Meteorological Organization, we have the National Weather Service, we have NASA, and we have the National Oceanic and Atmospheric Administration, and their acronym is NOAA. And you'll be seeing a lot of them in the next couple of weeks because a lot of our data and a lot of our satellites are controlled by the NOAA. So when we say that climatologists study climate, they can do this in a few different ways. They work with several different governments, agencies, organizations. They can be working with the public data. They can be working for a private company. They can be working as a consultant. They could be working for a nonprofit. Generally, what they're looking at is they're looking at samples of air, water, soil, as well as historical data that we've already collected from a certain place, both current and historical, to decide what the climate is and whether it's changing or whether it has changed previously. Climatologists also do a lot of work with meteorologists, which are people who study weather, to improve weather forecasting and to make it more accurate in their predictions by looking at what has happened in the past and looking at what changes they predict happening with the climate in the future. Before we go on to climate classification, I want to go over just briefly a few different tools that climatologists use when they're looking at this different data or they're collecting data. A couple of terms that I want you to know are barometer, which is an instrument that measures air pressure. We have a hygrometer, which measures humidity or the amount of water vapor that's in the air. This one you should know already is a thermometer, which measures temperature. Those can be digital. Generally, you don't see analog thermometers anymore. Digital is more precise. And then we also have satellites and computer simulations. Um, it's Satellites are where we get the data in the video that you saw yesterday for your bell ringer, tracking heat, dust, aerosols, which are air particles or particles of salt, smoke, dust in the air. Satellites can also track elevation. They can track the movement of water. They can track the movement of clouds. Um, and they do this in a few different ways. So, for example, we have the GOAS-R satellite, which is from the National Atmospheric and Oceanic Administration. Um, that is one of their big projects that they have. They have several of these satellites up right now, tracking data in different ways. These satellites are outfitted with different cameras and instruments that can not only see visible light, like taking a photograph, but they can also um, interpret data on other parts of the electromagnetic spectrum. So, for example, infrared or near infrared wavelengths, some of them have UV filters. Here's an image from one of those satellites that tracks dust, smoke, haze, and clouds using visible light. We have another one that tracks vegetation or plant growth, and that one uses near infrared waves to look at that data. We have another one that's also near infrared, but it's at a different wavelength, so this one looks specifically at snow and ice. You can see a lot of that over the Atlantic in this shot. If we go into the infrared wavelengths, we can look at water vapor in the atmosphere, and you can also see it over the oceans as well. And then, of course, they have your standard visible light cameras that can do this true color imaging where you can get an actual image of what the Earth looks like. One last tool I want to talk about is Doppler Radar. Doppler Radar is the kinds of images that you see when you look on a weather map or a forecast. Basically, the way that Doppler radar works is you have a tower that sends out radio signals, and those radio signals travel until they hit some kind of particle. In this case, you're mostly looking at ice or water vapor or rain. And when it hits those particles, some of them bounce off in other directions and some of them bounce back towards the tower. And the tower listens for that return echo. So it can tell where something is and how fast it's moving, and you end up with weather map images that look like this, that tell you where a storm is, where it's moving, and the density of the clouds, so how strong your storm is. Continuing with climate, we're going to talk a little bit about climate classification types. So we talked about how no two climates are identical, but there are a lot of climates that are similar enough that you can group them together. And depending on what criteria you use to group them, you have a couple of different classifications that you can use. So some of your classifications are going to use temperature and precipitation to group climates together. Other ones are going to use latitude, altitude, humidity, or other factors. Some of these different types are more useful for certain types of scientists than for others. So, for example, if you're a biologist, you might be more inclined to use a life zone classification that tells you what kind of plants or animals can live in a certain zone. But if you're a meteorologist or a climatologist, you might look at a classification type that uses precipitation and temperature rather than biological factors. The big classification system that we're going to talk about is the Köppen climate classification system. It's one of the more widely used classification systems. It separates climates into 5 main types, which we'll list in a minute, and then it further separates them into subtypes based on their temperature and the amount of precipitation, and in some cases, when they get their major precipitation, whether it rains more in the summer or in the winter, when their dry season is, things like that. On the right of this screen, you can see an example of a Köppen map of the United States, and I'll show you some more examples of those in a minute and teach you how to read through them. So the Köppen system starts with this 3-letter code, or in some cases a 2-letter code. So the first letter of this code is going to tell you one of those 5 main categories of climates that all the Köppen gets sorted into. So you've got A, B, C, D, E, okay? A means equatorial. Those are climates that you find around the equator. That includes things like tropical rainforests. We've got climate type B, which is an arid climate, which means it gets relatively little rain. In most cases, this is going to mean deserts. In some cases, it can mean grasslands as well. You've got climate type C, which is a warm temperate climate. We've talked about temperate climates before. You've got climate type D, which is a snowy climate. You often see this on maps around mountains. And then you've got climate type E, which is a polar type climate. And you usually find these at the poles, the North and South Pole, or at very high elevation, way up in the mountains. And you can see pictures of each of those types, so you get a little visual to associate with each of those on this slide. Now that you've got your big 5 categories out of the way, you're going to start breaking each of those big 5 categories up into a smaller subcategory based on the amount of precipitation that a place gets and possibly based on its temperature if you need to subdivide it a little bit further. Remember that the Köppen codes can have either 2 letters, in which case you've got a main type and its precipitation, or they can have 3 letters if you want to include the temperature with that to get a little bit more specific. So you've got 2 charts here. The first one on the left tells you the second letters that you might see paired with that A, B, C, D, E, F. You've got several different types, 6 different types. You've got deserts, steppe, which is like a grassland at a slightly higher elevation. You've got fully humid, that would be us. We're an example of a fully humid climate. You've got places that have dry seasons in the summer. You've got places that have dry seasons in the winter. And then you've got monsoonal regions. And a monsoon is a very heavy period of rain in a very short time. That third letter is shown on the chart on the right, and that gives you an example of some of the different temperature types that you're going to see with the Köppen system. So you've got hot arid, hot deserts. You've got cold arid, which is cold deserts, places that have hot summers, warm summers, cool summers, places that are extremely continental. And then you've got polar frost and polar tundra. The difference between those last two being that polar tundra is a little bit more extreme and colder all year long. So this is an example of what that all looks like when you put it on a map. You can see across the top here that they've color-coded all of the possible combinations of the 5 types and the 6 precipitation types and all of the temperature types up at the top. You're always going to see these keys on the Köppen maps. I am not expecting you to memorize these different codes, but I do expect you to be able to read this type of map if you're given a key. And we're going to zoom in detail here in a minute, but first, we're going to jump over to Google Earth and take a look at what a Köppen map looks like in 3D. So in this case, I've taken a Köppen map and laid it over an image of the Earth, and you can see all of these different colors with the key on the left in this case. And it's even got the different 5 types with it, and it's got the name codes with it. And I'm zooming in right now in the United States. You can see we're in green. That means we're a warm, temperate climate. And if you read into that code a little bit further, it would be fully humid for precipitation. You can see how it's more arid around the western United States, the Rocky Mountains, but then it gets into the boreal or more colder climates up high in the elevation of those mountains. That's the purple and blue that you're seeing. When you go further north into Canada and into the northern United States, you see a lot more purple, which is a lot more boreal. And then if you get far enough north or into the mountains up the west coast, you're going to see a lot of that blue polar, and you're going to see a lot of that gray boreal as well. That just means that it's colder all year long. So we're going to zoom out for a minute and go over to another part of the world. I'm going to orient my map here so that you're looking at it with north at the top. And right now we are hovering over South America. You can see in that red and that dark red, those are the equatorial climates. So that should give you a hint that the equator goes right through those places. You're actually looking at a lot of Amazon rainforest in that location. But you can see right next to the rainforest, we've got a nice streak of blue coming down the side. So that's more mountains, that high elevation and those cold temperatures. Coming around, you're seeing the southern tip of Africa right now. So again, you're going to see some red right in the middle around the equator with that Congo rainforest. And then all of that yellow and gold that you see up at the top is a hot, dry desert. That's the Sahara. So if this map, if you had a key right here that you could see that that was hot and arid would be the code for that. Madagascar is a place that we're going to talk about later, probably next week as well. It's a really interesting study in climate because you've got this equatorial rainforest and the temperate rainforest that actually form a rain shadow. There's a ridge of mountains right there. And that's what I'm hovering over right now, that gold, that desert. Those mountains block the rain from coming past the mountains, and that's why you have rainforest on one side of the mountains and desert on the other side. So scrolling over to Asia, you can see more of that rainforest, but you can also see a lot of blue up there at the top and some purple as well. So again, you've got these very hot and very cold climates right next to each other, and a lot of that is going to be because we're right over the Himalaya mountains right now, so you're seeing a lot of change in elevation. So you're going up thousands of feet, it gets much colder up in that blue area, and then right over here, you're looking at a cold, arid location, so a cold desert is what we're on top of right now. Continue going north into Mongolia and into Russia, and you get back into those boreal climates, that boreal forest, the taiga that we talked about. And then you scroll back over and you are back into the Middle East. You're back into a hot desert climate. So again, things can change very quickly when you look at it on a map like this. You see all that green right there. There's the warm, temperate climates of Europe. So a lot of forests, a lot of deciduous forest you're going to see in that location. So these Keopen maps can look a little bit overwhelming at first, but they're very useful once you get to used to reading them. So we're going to do a lot of practice with that over the next couple of weeks. I promise it's not as hard as it looks at first, especially once you have a key and you're able to piece together those codes. So just keep this in mind. We're working on getting you the software where you can look at this globe on your computer as well, but tech hasn't pushed it out yet. But for now, we're going to jump over to a 2D map and give you a little bit of practice reading it on those. So here's an example zoomed in from that 2D Keopen map that I showed you before we went over to Google Earth. In this case, I've zoomed in on North Africa. So you can see in that gold area up at the top, it's got 3 letters. Up there it says B, capital W, and then a lowercase h. So if we go back to our key and we read that 3-letter code, B is one of the 5 main types. It means it's arid, which means it has relatively little rainfall. Going a little bit more specific with that, the W means we get desert-like precipitation, which means very, very little precipitation. And then that lowercase h tells us that this is not just an arid climate, but a hot arid climate. Okay? If we go down a little bit further into the light pink, you can see where it has an AW. That AW, the A, is one of our 5 main types. It stands for equatorial, which means we're getting near the equator. And then the W says that we're dry during the winter. So in this case, the information the map is giving you is that this is near the equator, and it has a dry winter, and then we can assume from that that it has a wet summer. So here's another map. Hopefully this place looks familiar. This is North America. You can see the United States right in the middle. You can see Canada sitting on top in purple and blue. What I want you to do with this map is I want you to identify those three questions that I have at the bottom. So what does DFC stand for? You can see that that's the purple up at the top of the map. I want you to look back at the key earlier in these notes. Hopefully you wrote it down. And I want you to explain what each of those letters mean. Then I want you to find Mississippi on this map, and I want you to describe what kind of climate zone are we in. Find the color, find the letters that go with it, and then I want you to again look back at your key and tell me what those letters mean. Okay? And then lastly, I want you to find the west coast of the United States, and I want you to describe to me, based on what you see on this map and what you have in your key, what the climate is like on the west coast. Once you've got all of that completed, I want you to double check your notes. I want you to bring them to me, and then I'm going to stamp them, and you can move on to your next assignment. Hope you guys have a great time.